Sainath, good evening. Bharati, Ruchita, good evening. Questions. Your poll will be started, but I will extend the time. Don't worry. Let me do some corrections. Determine the minimum number of 2-input NOR gates required to implement 1-bit magnitude comparator. I am starting the poll. I will give you sufficient time. If it is a 1-mark question, 1 minute, I will give you 2 marks question. I will give you 2 to 3 minutes of time. So let's start. Ganesh, remaining people, any problem is there? Please comment. Then we change the network. I tried the earlier one. I will refresh. It will refresh again. Don't worry. Is it fine now? Okay, no problem. So let's move. Let's move to the next question. I will start the poll. So let's move. Let's move to the next question. I will start the poll. Previous poll is over. Leave it. Previous poll is answered by some people. So leave that question. I cannot take it again. Don't. Very good. Very good. Time chahiye to I will extend. That is sufficient time for this question. Very good. I am not sharing the score. Okay, I will share the total score at the end of total questions. Yes, I am. Please understand, Sushil. I start the poll. I am extending the poll. There is one option for me to extend the poll time. With the question, poll also starts. But I am extending it. Don't worry about it. So read the question. I will start the poll. One minute. Your poll started. Right. Next question. Ready? Shall I start the poll? Read the question first. In a n-bit carry locate adder with inputs an minus 1 and so on a0, bn minus 1 and so on v0, c0 equal to initial carry equal to 0, determine c2. Right. Let's start the poll. This is invert. It is in next. This is invert. It is inverter, not diode. Please see inverter. Okay. So read it. I will start the poll. Deepak. Next question. Get ready. Very good. Next question. Get ready. So it will make a quick revision for your previous topics. Next question. I will give you 1 minute time, then I will start the poll. So it depends on the question. I will change the timings. Okay. So start the poll. This is 0. Good evening, Lucky. Is equal to 1 by 8 of clock applied to the first stage also has a periodicity, that is time period equal to 1 by 8 of output signal obtained from the last stage. So from this what you can say, f is also equal to 8 times f naught, because time period is divided by 8, frequency will be multiplied by 8. Now these two you relate, both are f's na, so f clock by 8 equal to 8 times f naught. Then what is f naught? F clock by 8 and 8 will give you 64. So what is the answer? Mod 64. Simple question, but tricky terminology. Even you don't understand the question, Luckily 8 and 8 multiply karke you can say 64. Okay, but it will not work every time. This is the concept you should understand. Converting the question into statement will give you the answer. So shall we move further? We cannot guess. You cannot guess. You may guess it as 8 into 8, 64. It will not work every time. If time doesn't permit, leave the question. At least you get negative marking saved. Never try, never do guesswork. Okay. So simply here 8 into 8, 64 can be done. I don't suggest those things because if I say something, it should work for every question. Then only I will say. It may work here, not every time. So you want to give one answer, then we may think 1 by 8, 1 by 8 as 64. Okay. Let's go back. This everybody knows because we discussed it already a number of times. What is this? Master slave. Master is clock is 1, master will work, clock 0, slave will work. This part discussed in last doubt session also. Go back. This is tomorrow. This fellow, please listen. What is this circuit? SR. It is not JK man. JK man, you will be getting feedback and all those things. It is a SR flip flop. For SR flip flop, there is no race condition. Race condition will be occurring for whom? That is for JK. Invalid conditions will occur here. Race around condition will occur for JK flip flop. Don't tempt with 1-1. ये तो tomorrow है. Tomorrow. ये तो simple बात है. Listen here. Any problem, Rahul? What do you mean by race condition? Output toggles multiple times in the single clock. Okay, it will not occur in D flip flop. How it will occur? D flip flop is having only one input. In T, it may be possible if it is level triggered. T for toggle. So come here. It is a JKRT in the toggle mode. Please see here. Our table, you just remember. Clock is Q bar. And what is the triggering? Positive. I told some logic now. Q and positive means the same sign. Q bar positive means opposite sign. Opposite sign means up. I told. Simple rule. Opposite sign means up. If it is up counter, if it is 3, next clock will be 4. Because it is ripple counter. Okay. This logic I told yesterday class already. Simple. One step may how to do this. Q bar is clock input, triggering is positive. If Q and positive comes, it is down. Q bar and positive comes, it is up. Opposite sign is up. Same sign is down. That shortcut I told. Go back. So what is JK flip flop characteristic equation? Qn plus 1 equal to JQn bar plus K bar Qn. He is saying that J equal to 1, Qn equal to 0. So J equal to 1, Qn equal to 0. So K bar into 0. So 0 bar is 1. That's all. It will not toggle here. Qn plus 1 will be equal to, already 0, it will become 1. Okay, then in that way you can say it will be 1. After applying 1, the next state you will be getting 1. Simple rule, Qn 0. Okay, you can also do like this. So JK flip flop, one of the input is 1, other input is 0 or 1. In this case, anyway 1. In this case, Qn bar. What is Qn bar, sir? 0 bar is 1. Like this you say, it is answer same. Okay. Or from the always I love characteristic equation. Because it will give all answers. Everything can be done from this. conversions, everything will be helpful. This will help you for any single case. Okay, right. Next, shift register can be used for serial to parallel conversion. Counter is used for frequency division. Decoder is used for memory addressing. Very simple question. So P is 3, Q is 1, 3, 1, 2. Decoder, one of the important application is memory addressing. We will use it to select one memory device. Memory blocks are there. Okay, you say 3 to 8. You give address, one particular 8 KB is there. 1 KB, 8 blocks are there. Based on the address, it will select one address at a time, one block at a time. Next, very simple question. This one, master slave. We discussed this in the class now. The change in the output occurs when the state of slave is affected. I told this clearly. Slave output is the final output of the JK master slave JK flip-flop. Change in the input immediately reflected in the output. No, master only changes. Slave will change when clock becomes 0. Change in output occurs when the state of master is affected. No. Okay, master will affect. Original output will be slave. Right. Both master and slaves are affected same time. No. Master is positive and slave is negative. Okay, shall we move? Tomorrow. Very good. What is your doubt, Bhargavi? Only slave becomes 1, then only, yeah, when slave clock is 1, then only your output will be transferred from master, right? So now see here. This question, one simple way to solve it is, listen, toggle mode you can say. Two different ways I will tell you. Initially you assume this is 0 and 1. J Q bar assuming initially cleared 0. Okay. Then clocked 6 clock pulses. The sequence of output is this is 1. So apply first clock pulse. This is the condition now. So in the first clock pulse when you apply, what is the output you get? What is the input to the JK flip flop? 1 1. You get 1 0. This 0 will go here. Now second clock. Please understand, second clock 0 1. 0 1 means you get 0 1. This 1 will go. You should not analyze immediately 1 1 as the output. Please listen. You applied the input, you got the output. This feedback will go back but will not affect the output until you apply next clock. Now it will read 1 1. What is the answer you get? Previous bar, that is 1 0. This 0 will go back, but it will wait for next clock pulse because flip flop will change only once in one clock pulse. Okay, actually in the figure, you should provide this also. Edge triggering. Okay, so now again 0 1, you get 0 1. That is the process you will be getting. That is the 0 1 0 1 0 1 0. So this is the answer. This is one method. If you don't want, you can do like this also. Qn plus 1 equal to, formula is what? JQn bar plus K bar Qn. So what is your J Q bar? Plus K bar into Qn. This is Q bar. So toggle. So initially 0, 1, 0, 1. That's all. This is always your friend is characteristic equation. Next, switch tail D. That is D to Q bar. Okay. So now you take one line and switch tail means what? If you say ring, Q should be connected back. If I say switch tail, who should be connected back? Q bar should be connected. Switch tail means Johnson. Switched tail or twisted tail, Johnson only. So this figure is already analyzed in our class earlier. What is that? Qn plus 1 equal to, what is that? Q bar. What is this mode? It's a toggle mode. Na? So you can say it is related to T flip. Most related to T flip. Every clock it will toggle. Clock is there, it will toggle. No clock, it will not change. Like that. You know, Qn plus 1 equal to D, but D is connected to Q bar. Next, already you know this, synchronous counters are faster in operation compared to asynchronous or ripple counter. Tomorrow, this is a simple question. 0, 1, 1, 0. These two are given back with XOR gate. So when you apply first clock pulse, XOR of 1, 0 is 1, 0, 1, 1. XOR of 1, 1 is 0, 1, 0, 1. XOR of 0, 1 is 1, 0, 1. This question we have done or not in the class already, similar model. Next, this is a direct connection, SR to T. S must be TQN bar, R must be TQ. How to remember easily is, you know this figure na? SR to JK. Anyway, we know this figure from basic analysis. Okay, from this figure you remember already. So S must be J Q, R must be K Q bar. Here JK to T replace J equal to K equal to T. This is what you should have to remember easily. Instead of doing all those tables and conversions, then what happens? S must be TQN and R must be KQN. But I made wrong or what? JQN bar now. Right. Next. What is that tomorrow? What happened, Asif? Any problem? Next means why after 3, 5 comes? What about 4? Okay, it is originally 4. This is tomorrow. Last question. Who is that Pupul favorite question? Okay, you understand here. VI greater than 2 equal to 1. Else 0. What about here? Vi less than or equal to, what is that? Minus 1. It will give you 1. Else 0. Because it is connected to negative terminal, here it is connected to positive. Always positive greater than negative, then you get 1. Otherwise, you will get 0. Okay. So here, what is the question? First, he has given it is what is this? And it is SR NOR latch. Okay. So first question, first option A, Vi is equal to 2. Okay. Actual sense, Vi equal to minus 1. Thank you. Vi is equal to minus 2. So here you take this as S and R. What is S in that case? Minus 2 is more negative than minus 1. So S equal to 1. R equal to minus 2 means 0. So what is your P? It is 1. Understand, man? S is in the bottom, R is in the top. You want P. Okay. Nor may always keep that in your mind. S is in the bottom, R in the top, P is in the that Q is in the top. Okay. So this I name it as S. This I name it as R. You everybody understand this or not understand? Please ask me if you don't understand. So P equal to 1 will come. This is from NOR truth table. Okay. But I got 0 na, so wrong answer. Second option. Vi equal to 3. Now 3 is greater than 2, so S equal to R equal to. This is R na, R equal to 1. What about S? 3. 3 is greater than this minus 1, so 0. So 0, 1 will give you P equal to 0. Right. That's all. It's not a difficult question. D option. What is the D option? V option D. Someone having doubt. Vi equal to 0. Okay, Vi equal to 0. 0 is greater than 2. No. So R is equal to 0. What about S? 0 is greater than. This is also 0. Here, yes, it can be either 0 or 1. Actually, no change. Right. It can be either 0, 1. Okay, it is a no change condition. Right. D also correct, but out of the options, you want to select best is B. Okay. P can be either 0 or 1 or because he don't better to go for B. If we say no change, it is better. It can be 0 or 1, definitely correct, technically. But out of them, you want to select go for B, which is more perfect. That's what I'm saying, Alcha. It can be 0 or 1. But you should read examiner's mind also. He might be thinking something. Okay, he could have given properly as a hold or no change. So that's all. Not for today. I mean, from the quiz part. Let me upload. This DBB is clear now. Very good. Then let me give you one more DBB for today's homework. Tomorrow के लिए, I mean, DPP not over. You want me to make it over? I can make it. We'll see. If required, some discussion can be done. If not, we can end. Not an issue. Today, I'm happy we are able to do more number of questions. Let's do some questions from this also. Good question must be encouraged. Yes, Kuldeep once messaged me in group. I will add it in the drive. Yes, you are getting more answers. You are requiring more polls. So I will conduct a poll on this question. Yes, ready, guys. Try it. Equal propagation delay. The present input of input condition VQ is equal to 0. If the input condition is changed to 1, 1, then the output is right. This part we have already discussed. To avoid, right? And P1 is less initial conditions, initially 0 than TP2. Okay. Now you are having here Now assume this is having less delay. So this fellow will change first. 1 into 1 will give you 1, whole bar will give you 0. This 0 will come here. 0 into 1 is 0, whole bar will give you 1. Then this 1 may go back and it will not change further. Because 1 into 1 is again 1, whole bar is 0. So this is the condition. So you get 0, 1. If it is reverse, what is that? TPD2 is less than TPD1. Then you get 1, 0. So that is, this fellow will change first, then it will make it. So what is the answer? 1, 0 or 0, 1, depending on your propagation delays. If equal, I told already that it will toggle 0, 0 and 1, 1 kind of toggle, in the sense it is not valid, but you get some kind of 0, 0, 1, 1 condition. So let's move. All these are tomorrow class discussion part. Synchronous design. I'm not giving key intentionally so that sir, doubt there previously x and y given 1, 1. Yeah, what is the problem, Anuj? Tell me. Tell me, Anuj, what is your doubt? The present input, please read the question. Latch of the NAND gate, okay. But in equal, the present input condition is 0, 0. If the input condition is changed to 1, 1. So I took 0, 0 first and I changed it to 1, 1. Okay. Here 0, 0 is not hold state. For NAND latch, 0, 0 is invalid. My dear friend, NAND gate ka input 0. What is the output? Tell me. That's all. It's not NOR latch. Don't keep that table in your mind. Similar model question. It's not a difficult. Shall we do it? Poll. It's a direct truth table, man. NAND gate 0, 1. Very good. Let's make it. Oh, Abhinay and Alcha both are equal now. Mohan, Asif, Chanakya, Nishita, Matthews, Amitabh, Ruchita, and Vasistha. Okay, it is a simple truth table question. P xy is 0, 1. What about pq 1, 0? When it is 0, 0, you get 1, 1. When it is 1, 1, because it is invalid, when you give 1, 1, it can be, I told this logic, na, either 0, 1 or 1, 0, depending on propagation delay. This part we discussed in the class. 1, 0, 1, 1. Then what is that? 1, 0, 1, 1, 1, 0 or 0, 1. Next, let's do it. The 4-bit shift register is working like that. ABCD, the number of clock pulses to get 1111. You can do it, I think. Will you try or you want me to do? Already we did the same model. But here XOR should be between. You can try. 1101. Because it is your DPP, you should try. 11 if you try. Last question for today's class. Okay. One minute. आपको आंसर ऑप्शंस चाहिए क्या? As you like polls, let's do the polls. So this is final. As 31 polls किया. Why Ganesh? What happened? As 31 polls किया total. One more चाहिए तो because Ganesh asked me, let me do it. This is the last question for today's class. दिल मांगे more चाहिए तो ले लीजिए. Read the question. ये तो previous year's question. Start the ball. Wait business नहीं. Start. Very good. Abhinay, Aditya, Asif, Mohan, Matthews, Chanakya, Nishita, Amita, Ruchita, Vasista. Okay. Thank you, Deepak. So what is the right answer? पार्टी के बाद 50 भी राउंड फिगर होता है. Very simple question here. 37 minus 32 equal to 5. So this is 6 na. 6 minus 5 equal to 1. That much simple question. If your analysis is good, let's do it properly. It's a mod 16 counter. Okay, mod 16 mein it will count 0 to 15. Then again 0 to 15. So it is the clock, 16th clock. 1 minute. 15, again 0 to 15, 0 to 15. Like that, it will continue the same thing. So after every 16 clock pulses, it repeats the same. So you should do the operation called mod operation, which will give you 5. That is, subtract 16s from this. After 16, it is repeating na remainder of the division of 37 by 16. Okay, so what you will get? 5. So it is whatever you get the answer for 5 clock pulses. Why to know? Because if you read, you can know. How to know? By reading the question. Okay. So now 6 is there. Okay, 5 clock pulses. First clock pulse it is 5. Second clock pulse it will be 4. Third clock pulse it will be 3. Fourth clock pulse it will be 2. Fifth clock pulse it will be 1. Just subtract 5 directly. That is the answer. क्या आसिफ भूख लग रहा है क्या? Last, final, and again final. Okay, so no more last question I will do. No problem. So everybody understand this? Anyone having doubt, please ask. It is a modular operation. It should after every 16. Okay. If up, then add 6 here, add 5. That's all. Here subtract, decrease na, there increase. Examiner is good like me. That's why he give up and down both answers. So some people want one more question. Let's do it. I didn't get you, Anush. Surprise quiz to ho gaya. Analysis means what? You got the poll ratings na? I didn't get you, Anush. Please ask me what is your point. Read the question. You have a shift register shown in the figure initially loaded with the bit pattern 1010. Subsequently, the shift register is clocked with each clock. First, the pattern shifted 1 bit. With each shift bit, the serial is pushed to MSB. How many clock pulses will be? again to get back 1010. If you are ready, I will start the poll. Try. I will also try. क्या मैंने गलत दिया क्या? इतना रॉन्ग आंसर्स क्यों आ रहा है? 1010. I have given wrong. Okay. So let's check 1010. It is XOR operation of these three. Then you get 1101. Okay, these three will give you 0110. Okay, so 0011, 0001, 1000, 0100. Okay, then 100 will give you 1010. I'm sorry, 1, 1, 2, 3, 4, 5, 6, 7. So let me give one last question. Number of ones in a 15-bit SISO is counted by determine number of flip-flops required. In the count. Otherwise one will change. Last question. It's a previous question. So from these subjects, digital networks, control signals, these subjects, don't try to lose any particular mark. Prepare like you will be able to answer all the questions from this. Even paper is tough. These subjects will save you. Lastly, final leader poll is Abhinay, Aditya, Mohan, Asif, Matthews, Chanakya, Nishita, Ruchita, Amitabh, Vasista with one wrong answer. So otherwise, that is the poll. So one more you can do after class, Asif. Right. And now listen here. The number of ones in a 15 bit. So maximum ones equal to 15. Minimum ones equal to 0. That is, what it is doing is you have an SISO. Some data is there in SISO. This is given as a clock input to the counter. So when this data is transferred, whenever one comes, the counter will count. So like that, counter is counting number of ones. Counter is counting number of ones. Okay. So now what we need to do is counter is counting number of ones. Whenever one comes, the counter will count. That is the arrangement he made. So how many? So what is the number of ones in a 15-bit SISO is counted by clocking SISO output to the mod and counter. Determine the number of bits required in the counter. So counter should count from counter range is 0 to 15. What is this? Mod 16. If it is mod 16, how many number of flip-flops required? Number of flip-flops or bits same. Okay, number of bits and flip-flops are same only. Understand? You have some data in the SISO. Every time one bit comes, okay, you should store it, you should count. Okay, 15 bits are there now. There is a chance of all 15 ones, all 15 zeros. So your counter should be having the capability to count all zeros to 15. That is 0 to 15 it should count. Why 2 mod n is required? What is 2 mod n? It is mod 16. Number of flip-flops is equal to log to the base to 16, which is 4. What is your doubt, Asif? Please ask. Where is that? I made something wrong. Oh. So that's all for today. We'll meet tomorrow. Tomorrow we'll be discussing decoding errors, transient states, and asynchronous counter delay, and asynchronous counter mod and counter modulus finding, and then we may start synchronous design also. So we'll start tomorrow. Thank you again. Good night all. You have any doubt, ask me, Abhinav. Good night. Thank you, Danpal. Abhinav, please message if you have any doubt. Otherwise, I will end the session. Good night, Harshvardhan. Good night, Krunal. Vasista. Where is he, Abhinav? He's not there. Okay, Robert, we can plan. Abhinay, add your question again. It is cropped up and down wrongly. Please make it properly. All your DPP questions. Okay. Thank you, Aditya. Please ask it in the group. Thank you, Himasri. Abhinay, please add your question again. I think you are asking this one. Okay, ask in the group, Abhinay. No problem. Anything is fine. Thank you, Amitabh. Good night.